In this video, we're going to take a quick look at XML, which is the extensible markup language. Our first look at XML was from Ajax when we talked about asynchronous JavaScript and XML, where the data that is managed by Ajax XML HTTP request objects could be stored in XML documents. And this video will look at XML more generally. So where does XML come from? Well, there's a language called SGML, or Standard Generalized Markup Languages, that allows one to define a whole lot of different markup languages according to your domain. So for example, HTML is a markup language. It contains a set of tags or a set of markups, start and end tags and so on, which needs to be structured in a certain way. Right? Certain tags need to be nested within other tags and so on. So you can define all kinds of markup languages, not just HTML, but other markup languages. But HTML was too complex. So instead they came up with something called XML, which is a way, or if you like, a standard to describe document content or to create your own tag languages. So those marks, those tags, if you like, are used to describe the data. So if you think of HTML and if you think of the title tag and the header tag, you have a string, which is the title, and the title start and end tags are used to provide metadata or information about the string. It says that that string is a title, for instance. So this is a picture of the different languages. You have XML, which is, if you like, a simplification of HTML and a generalization of HTML. So with XML, you can define your own set of human readable tags. You can define your own markup data, and you can use it to design your XML languages for electronic data exchange and real estate information and so on. There are many applications. Right? So XML, because of the markup or the tags that you can define, allows you to define semantics. So if you go through all the markup or all the tags on your HTML pages, the tag names provide semantics. It tells you a title. It tells you that a string is a particular title, or that a particular string is a header, and so on. And what could be in the tag names? Generally, they are Unicode. In other words, it's not ASCII, but it's more than ASCII, right? It's a 16-bit code. And because it's 16-bit code, allows you to define 2 to the 16 different characters, right? With 16 binary digits. So in others, you can have 65,000 multilingual character set. And this is certainly to accommodate languages like Chinese or Japanese and Arabic and so on, right? These languages have a much larger character set compared to English alphabets, for instance. Okay, so XML started in 1996, and then has been standardized uh, quite a long time ago. What does XML actually means? So XML can mean a way of defining your own markup languages, but XML in this regard can also mean a family of different formats and technologies. So when you say XML, XML is actually a package. So it refers to XML schema as a way to define the structure of XML documents. It refers to some related technologies like XSL and CSS and XSLT, right, which we'll talk briefly about. It also refers to these other formats or standards like XPath, a way to define a link to parts of documents, something like the anchor tag, but much more general. And then you have Xlink and Xpointer, which are, if you like, generalizations of the URL idea. And then Xquery, which is used to query, is like SQL, but for XML documents. And we have seen the DOM model as a way from within your JavaScript programs you can access HTML information, and similarly within your JavaScript code you can access XML information by using the DOM model. And there's another model which we will not look at in this subject. It's called the Simple API for XML, or SAX model. But we're going to just use the DOM model for our purposes. So there are different types of XML languages defined, or markup languages defined for domains like chemistry, astronomy, mathematics, and so on. So all these are just different set of tags. HTML is a hypertext markup language. So all these are just different set of tags that you can use to mark up different types of data. When you want to create your own XML language, you must know requirements, you must look at the application, you then define a data model and represent your data model using a DTD or an XML schema, and then you can write the XML documents that conform to the DTD or XML schema and then test it. So we will look at examples of DTDs and XML schemas this week and next week. Okay, elements and tags. Right. So remember that a tag is the string with the less than and greater than sign, and then there's a tag name in there. But an element is actually the combination of the start tag and the end tag and what's in between, which could be other elements or just a string. So for instance, in this example here, you have the customer element, and in the customer element you have two other elements, the name element and the age element. And you can see that the customer element has a start customer tag and an end customer tag, and the name element has a start name tag and an end name tag, and the age element has a start age tag and an end age tag. So the customer element here is a complex type because it has other elements in it, whereas the name element is a simple type, right? Because there are no other elements nested inside the name element, and similarly age is a simple element as well. In an XML document you have prologue, and which are some declarations that you have, and then the body, the actual elements that you have, and then the epilogue, which is some comments at the end. So here's an example, and you can see the first line there, right? And that's quite typical, and to show the version of the XML, and which is standardized at 1.0. There's the encoding, there's a Unicode encoding. Remember that Unicode encoding means that you have 16 bits for the tag names, and which means that the tag names might not just be English words, but the tag names could be Chinese, could be Japanese, could be Arabic, could be any language. And standalones, yes. And then you can link to a style sheet, which is then used to display the elements in this XML document, in the body, the elements in the body. And then you have the epilogue, which is just some comment. So a bit of terminology. Entities are XML files or documents, and they are called entities. Data is part of the XML document, and you may have data which is parsed or unparsed. So parsed will hold character data, for example, data that follows the English alphabet, for instance. And then you have unparsed data, which is non-character data or binary data, like if you look into a JPEG file or and some image file, right? That's unparsed data, the binary data. So when you have tag names and you have names of attributes, there are some rules, and you cannot have spaces. So you cannot have a tag name called La Trope with a space between La and Trope, for instance. It has to be one word, La Trope, without the space in the middle. Must begin with a letter, so you can't begin with a colon, for instance. And you can have a colon or underscore in the tag name. And later on you will see that the colon actually can be in a tag name, but it has special significance to indicate namespaces. fields in an XML document. So elements are often nested hierarchically, as we have seen, and must be nested correctly, and all the text must have an ending tag. These are some conventions in XML. So here's an example. You have elements, and you have nested elements, or elements contained within other elements, and then you have the attributes. And attributes normally contains the value in double quotes. Right? Whether it's a number or a string, it's always in double quotes. And in general, you notice that we use lowercase for attribute names and for the tag names as well. And we have XML strings, which is the basic data type in XML. And just to reiterate, the element is prod, and then you have the start and end tag and things in between. Okay, so you can follow some links for further information about Unicode values. You can also have special characters like ampersand, apostrophe, quotes, less than or greater than. Right? So these are special characters that you can embed within your XML document. And the reason for having these special characters is because if you write the angled brackets less than or greater than, they have special significance, right? So to avoid any confusion, if you want to write less than or greater than, you have to use ampersand LT or ampersand GT. Okay, so you can also define abbreviations for strings, like instead of everywhere writing XML beginner's guide, you can declare what is called an entity, which is an abbreviation for that, call that title, and then ampersand title will be replaced by XML beginner's guide everywhere. Okay, so you can delimit scripts and other non-markup text from the browser as well, and this could be important to keep the page from crashing. Right? So for instance, if you have some contents, like the contents about the publisher price in this example here, and you do not want the browser to process those contents, so what you do is you can put it within this symbol, the exclamation mark, and then C data, and then those square brackets. So anything within those C data square brackets will not be processed by the browser. It's like a comment, if you like. And then you can also have namespace attributes. So remember that a namespace is used to resolve name conflict. If you consider here an overloading or overuse of the name of the element name table, right? So in the first case, table refers to a HTML table. In the bottom case, the table actually refers to a physical table. So you're referring to information about a table. It's a coffee table, and there's a width and length of that table. So you notice that there's a name clash, in a sense that the same word table is used to denote two different types of data. So how do you differentiate between that? Well, the first table comes from a certain namespace, the HTML standard text. And the second table might come from an application-specific namespace, which is about coffee tables. One way to resolve it is just add a prefix H and F, and this prefix will qualify appropriately the name conflicts. Now H and F is a short form. Right? How do you ensure that these prefixes are done in a standard way, right, to ensure that the H and F that you use as prefixes are not just arbitrary? Well, what you can do is these H and F are actually short forms for the name of a namespace. So if you look at the first example here, you have H, which is a short form for that particular URL, homepage.cs.latrobe.edu.au/book, and F is actually a short form for homepage.cs.latrobe.edu.au/furniture. Right? So you have two different namespaces here, and although it looks like URL, these are not URLs. Right? It is just the name of a namespace, and it happens to use the format of URLs to be standard names of namespaces. Right? So this is just using the format of the URLs. They need not point to actual resources on the web. They are just used as names, and it can be a bit confusing, but the URL format here is used as names of namespaces. So why the abbreviation? Right? Of course, instead of writing H, if you write the full URL before every tag, it's going to get too messy. Right? So the abbreviation is just to make things look tidier. And you use something called XML and S to prefix the particular abbreviation, so that as a standard way to create these abbreviations. Okay, so just to reiterate, you saw this what looks like a URL, but it's not a URL. It has the same format as a URL, but it's actually a URI. So it's used as a unique identifier of a namespace, the name of a namespace, if you like. It's just a W3C, a web standard. So here's an example with the different things that we have seen earlier. And you can actually apply a style sheet. Right? So you have those elements like book, title, publisher, price, and you want to display this. So you can link from this XML document to a style sheet called style.css in the second line. And in style.css, you can have all the rules for the different elements that you have, like book, title, publisher, and so on. And when you render the XML document, load the XML document to a browser, the browser will follow the link to the style.css, load style.css, apply to the XML data, and generate this presentation like this. So notice there's a decoupling, right? If I want to display the same data in different ways, I just link it to a different style sheet. Some other examples of XML documents, I'm not sure if you have used RSS, which is just a format, quite a popular standard format for news feeds. Can you use CSS style sheet with RS? Of course, right? So depending on how you want to render these news feeds, you can just create your own style sheet if you like. So the same data can be presented in many different ways using many different style sheets. And this was quite a popular standard, how to invoke methods across the internet. So when you call a Java method, you supply the method name and the arguments. Well, that information, the method name and arguments, can be represented in an XML form. And this is an example of what has been called a simple object access protocol, where method calls are actually represented using an XML language, the SOAP language if you like. And you can see here that there's a method called getPrice, and which comes from a namespace called abbreviated as M, w3schools.com/prices. And then you have the argument of that method getPrice called apples. Right? So you can see here is a fancy way of describing a method call. So the web protocol can be used to invoke methods across the internet, and you'll find that this is a proposed standard for a while now, but it's no longer really used. It's very much replaced by something called REST, R-E-S-T, which is often called a REST API. So a REST API is basically a way to invoke methods across the internet using the HTTP web protocols. So you might have come across this term REST API, and if there's time, we'll come back to that later. Okay, so now we started off with the first architecture above. We have HTML web pages, which is the standard in the internet, in the web, and then you have HTML clients and HTML servers, right? And then with XML, you can also have RSS clients and RSS servers. So RSS servers just serves up RSS XML documents, right? RSS documents instead of HTML documents. And then you could also have SOAP clients and SOAP servers serving up SOAP messages. And so you can have a server that can serve up any kind of XML document, including HTML, and then you can serve it up to different types of clients. Or you can have a single client that can read all kinds, that can process all kinds of documents from all kinds of servers, and you can combine all of that together. So this is the modern web architecture. Generalizes from just processing HTML documents to XML documents in general. So I mentioned that XML is actually a collection of technologies, and one such technology is called XSL, or Extensible Stylesheet Language. And this is not to be confused with CSS, or Cascading Style Sheets. CSS is used for styles and layouts, whereas Extensible Stylesheet Language is used to transform a document. So if you have a HTML document, you want to transform it to an XML document, you can write the rules to do that transformation in a language called XSLT. So this is the style sheet syntax. So you can use an XSLT style sheet to transform a document, to rearrange the document. You transform it from one XML source tree to another result tree. Right? But we won't go into details for about XSLT. Okay, so XML is not a replacement for HTML. HTML has only a fixed set of text, so you can't replace it. It has its own structure, of course, and you can do validation. Is it a valid HTML or not? And when you generalize that, you can create your own markup language, and that's what XML is for. Right? So you can define your own text according to your domain. And just to point out, why is it called a markup language? So imagine imagine you're reading an article, a document, and you use a highlighter to highlight or mark up certain phrases that are important, or to highlight certain sentences which are important, right? When you use a highlighter, or you mark it up, basically. So it's the same idea here. So imagine you have some contents like this. You got information about a book, including its chapter, the title, and so on. And you want to mark up, you want to add some, if you like, metadata, which is data to describe data. So you wanted to kind of say which of these strings is actually a title, which of it is actually a chapter name, which of it is actually an email. So you want to mark it up. Well, you can add tags to do that. So in this example, for instance, you want to say that fundamental database system is actually a title. You can use HTML to mark it up, but you notice that with HTML, you only have a fixed set of text. You can't do too much, right? You can't convey too much of a semantics. You can say that fundamental database system is a H1 heading, but you really want to say that it's a title, right? So if you define your own XML language, like on the right hand side here, you can define your own set of tags. So you can define the title tag, author tag, email tags, and so on. And you notice here that with the addition of the tags to the strings that we are trying to describe previously, it is much clearer. Like which string is the email, which string is the title, which string is the chapter heading, and so on and so forth. Right? So that's the idea of a markup language. Right? It's used to mark up your text or your prose so that it becomes clearer. Now you can generalize, right? So we start off with an instance, and then we provide a markup of that instance. Now if you generalize, you remove that instance, and what remains is the metadata, or the markup, the tags themselves. You notice now that we have a general template for book information, right? So that's the idea of XML.